Please see the description for timestamps. There are two types of dilations. One is called an enlargement, and this occurs when your scale factor is bigger than 1. When we perform enlargements, we know that our image is going to be k times bigger than our pre-image. Let's look at an example. In this example, we have triangle ABC. We want to dilate it by a scale factor of 2, so it's going to be 2 times the size with the center at 0, 0, which is located at the blue point right here. So in order to perform a dilation that's centered at the origin, we could just take our coordinates and multiply our coordinates by 2 and figure out the location of our image. I think that is the best way when your center is at 0, 0, but we are trying to learn some properties of dilations to help us dilate about any point. So a way we can get started dilating is to start at our center and draw a triangle, kind of like a slope triangle from your center to whichever point you're trying to dilate first. So I notice that I'm going up 1 from my center and left 4. Because I'm dilating by 2, I want to make sure that my center of dilation has a slope triangle that's twice the size. So I need to be going up 2, right 8. So I can see that A prime is located at -8, 2. You could also think of it as starting at your center and you're going up 1, left 4, and then going up 1, left 4 again. So you're going up 1, left 4 2 times. I personally prefer to think of it as a slope triangle and then increasing that slope triangle or decreasing it according to the scale factor. So let's try this process for point B. So we're rising 2 and we're not running at all. So since we're going up 2, we need to go up 2 times that amount for the dilation with the scale factor at 2. So we're going to go up 4. And so B prime is going to be at 0, 4. For C, we see that starting at the center dilation, we go down 5, right 3. So we need to double that. So we're going to go down 10, right 6. So C prime is going to be located at 6, -10. There's a few important things to remember about dilations. One, we know that dilations create similar figures, which means we should have the same shape, just a different size for our pre-image and image. And looking at this, we can tell we have the same shape. And it's not just that it's this, like we have a triangle and now we have a triangle, but we can see it's like proportional, right? We also know that like A to B is a certain distance, and the distance from A prime to B prime is twice that length because our scale factor was 2. Same thing, B to C versus B prime to C prime. B prime to C prime is now twice the length as B to C. And the same holds for A prime to C prime compared to A to C. The other thing that's really cool about dilations is if you connect your pre-image and your image, that line will always pass through the center of dilation. And that's a way to know if you dilated around the correct point. We also know that dilations preserve orientation, so the way we move around our points stays the same. So A to B to C, we're moving clockwise. A prime, B prime, C prime, we're still moving clockwise. Let's try another example with a center of dilation that is not the origin. In this problem, we're dilating triangle ABC by a scale factor of 3, so we know our image is going to be 3 times the size of our pre-image, and the center of dilation is at 2, -3. So to get started, I'm going to go to the center of dilation and find the distance from the center to point A. So I rise 0 and I run 1. So if I'm trying to think of a slope triangle, I have a rise of 0 over 1. And if I'm multiplying that by 3, 0 times 0 is 3. So I'm still not rising anything, but I'm going to be running to the right 3 instead of 1. So I'm going to go 1, 2, 3. So A prime is going to be at 5, -3. Now that we know that A prime is at 5, -3, let's figure out where B prime would be located. So we want to start back at that center of dilation, and we want to figure out the distance from the center of dilation to the pre-image point we're trying to dilate. So 1, 2, 3, 4, 5. Notice how we didn't have to rise anything. So we're going to continue to not rise, but we're going to have to run 3 times 5. So we're going to have to run 15. So we've got the 5, 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. So B prime is going to be located at -13, -3. This is a good sign because we see that A prime to B prime is still a horizontal side, which is what we want. It's this like straight horizontal line segment. We also can see that the distance from A to B is 6 units. So if we're dilating by 3, the distance from A prime to B prime should be 18 units, which we can see is true because 5 to 0 is 5 units, 0 to 13 is 13 units, or 0 to -13, excuse me, and then 13 plus 5 gives you 18. So we can see that is on the right track. So now we just have to find the coordinates of C prime. So we are rising 1. Oh, actually the center of, let's make sure we're looking at the center of dilation. Okay, so we're going up 2, 3, 4, left 2. So since we went up 4, we're going to have to go up 12, 3 times that amount, and then left 2 means we're going to go up, or left 6. So we're just going to start at the center of dilation. We're going to go up 12, left 6. So C prime is located at -4, 9. Now we just have to make sure we connect our pre-image and image points, or sorry, all of our image points. So connect A prime, B prime, and C prime. And you should have a pre-image that looks like what's in black, and we should have an image that looks like what's in red. So we can see, again, we talked about the properties of dilations. We know that connecting your pre-image points to their image points is going to give you a line that passes through the center of dilation. And that's a way to verify that you actually dilated correctly. Sometimes it's helpful to use a ruler to really make sure you're being precise. We can also see that the distances are 3 times the amount, right? A to B versus A prime to B prime. A prime to B prime is 3 times the side length of A to B. B prime to C prime is 3 times B to C. And then A prime to C prime is 3 times A to C. We also see the orientation is preserved, and that's how you perform a dilation that's an enlargement.